くりレ夢ムです。ゆっくりマリサだぜ。
Hi, Raimo. Hi, Marissa. Hey guys. The number that shouldn't exist, but runs the universe.
ゆっくりしていってね。
The number that shouldn't exist, but runs the universe. Section 1. Hook. There's a number hiding inside almost everything you can see. It's inside the way your bank account grows. It's inside the spread of a virus. It's inside the curve of a nautilus shell, the decay of a radioactive atom, and the mathematics that makes your phone's GPS work. And here's the strange part. Nobody chose this number. Nobody invented it. Mathematicians discovered it completely by accident while trying to solve a problem about banking. So what is this number? And why does it keep showing up everywhere, even in places where it has absolutely no right to be? This is the story of E, the most mysterious number in mathematics. And once you understand what it is, you'll never look at the world the same way again. Section 2. The story begins. Let's go back to 1683. Switzerland. A mathematician named Jacob Bernoulli is sitting with what should be a very boring problem. A bank wants to offer compound interest. And the question is simple. If you invest $1 at 100% interest per year, how much do you have at the end of the year? Easy, right? $1 becomes $2. Done. But then someone asks a different question. What if the bank compounds the interest more often? What if instead of once a year, they compound it twice a year, 50% every 6 months? You'd have $2.25. Better. What if they compound it every month, every week, every single day? And here is where things start to get strange. Bernoulli notices something unsettling. No matter how many times you compound the interest, monthly, daily, every second, every nanosecond, the total never breaks past a certain invisible wall. It creeps up, and then it just stops growing. That wall. It's a number that starts with 2.71828, and it never ends. It never repeats. It goes on forever with no pattern. That number is E. Bernoulli didn't fully understand what he'd found. He just noticed the limit was there. It took another mathematician, a genius named Leonard Euler, to actually name it, study it, and realize just how deep this rabbit hole goes. Euler spent years investigating this number in the 1700s, and the more he looked, the stranger things got. Because he wasn't just showing up in banking, it was showing up everywhere. In nature, in physics, in probability, in places that should have had absolutely nothing to do with compound interest. So the question became, why? Section 3. The evidence. Let's look at the evidence. Because the case for E being something deeply fundamental and not just a banking curiosity is overwhelming. First clue, growth. Whenever something grows continuously, and by that I mean it's always growing, not just in jumps, E shows up. Population growth, bacterial colonies, the spread of an infection, the compounding of interest over tiny time slices. The reason is almost elegant once you see it. E is the only number where if you ask, what is the rate of change of e to the power of x? The answer is just e to the power of x. It doesn't change. The function is its own rate of change. In other words, E is the one number that perfectly describes things that grow proportionally to their own size. The bigger you are, the faster you grow. And E captures that perfectly. But that's just the first clue. Second clue, decay. Flip the process around. Radioactive decay, the cooling of a hot cup of coffee, the fading of a drug in your bloodstream. They all follow the same mathematical curve. And at the heart of that curve, E again. Every time. At first, investigators, meaning mathematicians and physicists, assumed this was a coincidence. Same formula, different context. Then they discovered something unexpected. Third clue, probability. Here's a puzzle. If you have a group of 100 people and you randomly shuffle their hats and hand them back, what's the probability that nobody gets their own hat? You'd think this changes depending on how many people you have, but it doesn't. As the number of people grows, the answer converges to exactly 1 divided by E, about 36.8%. Why? Nobody fully knows. But E is there, and that's the part that starts to feel less like math and more like a mystery. Fourth clue, Euler's identity. In 1748, Euler discovered what many mathematicians still call the most beautiful equation in all of history.
E to the power of I times pi plus 1 equals 0. 5 numbers, the most important constants in all of mathematics. 0, 1, pi, the imaginary number I, and E, all connected in one single equation. When the physicist Richard Feynman, Nobel Prize winner, one of the greatest minds of the 20th century, first saw this equation as a teenager, he described it in his notebook as the most remarkable formula in math. Nobody expected these 5 numbers to be connected. There was no reason they should be, and yet they are. Perfectly. Exactly. Always. Which raises the question that investigators have been wrestling with ever since. Did humans discover E, or did the universe build itself around it? Section 4, Theories. There are 3 major theories that try to explain why E is everywhere, and they lead to very different conclusions about the nature of reality itself. Theory 1. It's a mathematical inevitability. This is the most common scientific view. The argument is that E isn't mysterious at all. It just emerges naturally from the structure of mathematics. When you set up equations that describe continuous change, E is the only number that makes them work cleanly. It's not magic. It's just the shape of the math. In the same way that circles always have the ratio pi no matter how big or small, continuous growth always involves E. It's baked in. Inevitable. This theory is strong. It explains the banking problem, the growth curves, the decay functions. It makes sense. But then critics ask, okay, but why does the math work that way? That's just pushing the mystery back a level. Theory 2. The universe is written in mathematics. This is where things get genuinely philosophical. Some physicists and mathematicians, including some very serious ones, believe that the universe isn't just described by math. They believe the universe actually is mathematics. It's not that we invented equations to model reality. Reality follows equations because reality is made of them. If that's true, then E doesn't just describe growth and decay. E is the actual mechanism by which growth and decay happen. The number isn't a tool we use to understand the universe. It's a fundamental feature of the universe itself. The physicist Max Tegmark has argued seriously for this view. He calls it the mathematical universe hypothesis. It's an extraordinary claim, and it comes with a significant weakness. It can't really be tested, which puts it closer to philosophy than science. But it's hard to dismiss entirely, because he keeps showing up in places where there's no obvious reason it should be there. Theory 3. We're selecting for it. This is the skeptic's theory, and it goes like this. E feels mysterious because of confirmation bias. We notice when he shows up. We write papers about it. We call it beautiful. But there are thousands of formulas in science and engineering that don't involve E at all, and we just don't make documentaries about those that were pattern-seeking creatures. We find patterns even where there aren't any. And when we find a number in 5 different contexts, we call it a cosmic mystery instead of asking whether maybe those 5 contexts are more connected than we realized. This theory has real strength. Human beings are notoriously bad at assessing probability. We're wired to find meaning in coincidence. But here's the problem with this theory. The connections aren't superficial. Euler's identity connects 5 fundamental constants in a provably exact relationship. That's not a feeling. That's a mathematical fact. You can't explain it away with confirmation bias. Where does that leave us? Section 5. The most likely answer. Let's be honest about what we actually know and where the evidence is strongest. The mathematical inevitability theory is probably the most defensible. Here's why. When you look at what E actually is, not the mystical version, but the technical one, it comes down to a very specific property. E is the base of natural logarithms. It's the number where the slope of the exponential curve at any point equals the height of the curve at that same point. In plain language, it's the one number where growth perfectly mirrors itself. The rate of change is identical to the current value. Always. And here's why that matters for everything in nature. Real-world systems, living organisms, physical decay, spreading infections, don't grow in neat steps. They grow continuously, every moment, not just at the end of the year. And when you build equations that model that kind of continuous, self-referential change, E is the only number that fits. You don't choose it. It's the only thing that works. So in that sense, E isn't hidden in nature. Nature is the kind of thing that he describes. We just didn't realize it until we tried to write it down. But, and this is important, that explanation doesn't fully dissolve the mystery. It explains why he works. It doesn't fully explain why the universe is set up in a way where continuous self-referential growth is such a fundamental feature of almost everything. Think about it. Why do living things grow proportionally to their own size? Why does radioactive decay follow the same pattern? Why does probability keep circling back to this same number? Some scientists would say, because physics works that way. The laws of thermodynamics, the rules of quantum mechanics. These systems generate exponential behavior. And exponential behavior always pulls an E dot, but then you hit Euler's identity. And that's harder to explain away, because the imaginary number I, which describes rotations in mathematics, shouldn't have anything to do with E, which describes growth. And pi, which describes circles and geometry, shouldn't connect to either of them. And yet they all three meet at exactly 0 when you combine them the right way. That's not a coincidence. That's a signal that something deep is going on, that these concepts that seem completely separate are actually different faces of the same underlying structure. The most likely answer isn't that E is magic. It's that mathematics is far more unified than it looks. And E sits at the center of that unity. What we can say with confidence, E is real, it's consistent, it's everywhere, and it was hiding in plain sight for thousands of years before anyone noticed it. That alone is strange enough. Section 6. Conclusion. That here's what I find most remarkable about all of this. Jacob Bernoulli wasn't trying to discover a fundamental constant of the universe. He was trying to figure out the best interest rate for a bank loan. Euler wasn't trying to write the most beautiful equation in history. He was just following the math where it led. And somehow, through a banking problem in 1683, humanity stumbled onto a number that turns out to describe the heartbeat of how the universe changes over time. That number, 2.71828, is now inside almost every piece of technology you use. Your phone's signal processing, your GPS calculations, machine learning algorithms, financial modeling, medical dosage curves. It's everywhere, doing invisible work, because the math that describes our world keeps needing it. That we didn't put it there. We just kept finding it, over and over, in places it had no right to be. E.is that evidence that the universe is fundamentally mathematical? That reality is built on equations the way a building is built on blueprints? Or is it just a reminder that when you look closely enough at anything, banking, biology, probability, geometry, you start to see the same patterns underneath? That the world is more connected than it appears. Mathematicians have been arguing about this for 300 years, and they haven't settled it. Maybe that's the real mystery. Not the number itself, but what it says about the relationship between human thought and physical reality. Between the symbols we invented and the universe that seems to obey them. Did we discover E, or did it discover us? If you want to go deeper, look up Euler's identity, the Basel problem, and the history of natural logarithms. Each one pulls back another layer of how strange and beautiful this rabbit hole really is. And the next time you see something growing, a city, a tumor, a stock price, a wildfire, somewhere underneath all of it, that number is at work. 2.71828, still going. Never repeating, never ending, just like the mystery.